Equilibria. Introduction to Equilibria. All reactions reach dynamic equilibrium, which is when both forwards and backwards reactions happen simultaneously. Features of dynamic equilibria is when forward and backwards reactions happen at equal rate and concentration of reactants and products stay constant. If position of equilibrium favors reactants, so it's shifted to the left, then equilibrium mixture has mostly reactants. Le Chatelier's principle is used to find how changing external conditions like temperature and pressure affect position of equilibrium by shifting equilibrium into opposite direction to counteract the changes in the system. Effect of temperature on equilibrium. Temperature increase causes equilibrium to shift to oppose this change and move in endothermic direction to reduce temperature. Temperature decrease causes equilibrium to shift to oppose this change and move in exothermic direction to increase temperature. Low temperature can give higher yield to product, but will also mean it has a slower rate of reaction, so need to find a temperature which takes both into consideration. Effects of pressure on equilibrium. Increasing pressure causes equilibrium to shift to side with less moles of gas to oppose the change and reduce pressure. Decreasing pressure causes equilibrium to shift to side with more moles of gas to oppose the change and increase pressure. If the number of moles is the same on both sides, then changing the pressure will have no effect on equilibrium. Increasing pressure means high yield and rate of reaction, but hard to maintain as special equipment is needed and expensive to produce. Effect of concentration on equilibrium. Increased concentration of reactants makes equilibrium shift to oppose the changes and move to product side to remove and decrease concentration of reactants. Effects of catalyst on equilibrium. Catalysts have no effect on position of equilibrium, but it does speed up rate equilibrium is reached. Doesn't affect position of equilibrium because rate of forward and backward reaction increases by the same amount. Importance of equilibrium in industrial processes. Catalyst being used to speed up rate allows lower temperatures to be used, so there's low energy cost, but catalysts themselves don't affect position of equilibrium. High pressure leads to high energy costs for pumps to make pressure and too high equipment costs to have equipment that can withstand high pressure. Recycling unreacted reactants back in a reactor could improve overall yield. Methanol and ethanol used as fuel and to make methanol carbon monoxide is needed in hydrogen gas, and using carbon monoxide from environment can be seen as carbon neutral. And can be carbon neutral energy needed for reaction wasn't made by combustion of fossil fuels. Carbon neutral is activity that has no net annual carbon emissions to atmosphere. Equilibrium equation. Kc is equilibrium constant, and is found by multiplying all concentration of reactant to the power of its stoichiometry value together, then dividing by all concentrations of products to the power of its stoichiometry value together. How to find Kc units. Put all units, which is moles per decimeters cubed, and then cancel them out. How to calculate Kc. 1. Find moles of reactants at equilibrium by doing initial moles minus moles reactive for reactants, and for products do initial moles formed. Use X if value is unknown. 2. Then do moles divided by the volume in decimeters cubed to get concentration. 3. Then substitute into equation to find answer. 4. Find units. Effects of changing conditions on the value of Kc. Larger Kc means greater number of products. Kc is small means it favors reactants. Kc doesn't change when pressure or concentration are changed, and catalyst doesn't affect Kc2. Position of equilibrium and value of Kc change if temperature changes, and if equilibrium is exothermic then temperature increase will shift equilibrium to counteract the changes and move left in the endothermic direction. Value of Kc gets smaller because there's less products. Pressure changes position of equilibrium, but Kc stays the same. Catalysts have no effect on position of equilibrium and the value of Kc.